Welcome to We Have New Science Standards, Now What? Navigating the Document. This webinar is designed to help teachers or administrators who are not familiar with the document understand the layout, how three-dimensional science instruction helped develop the standards, and some key insights to navigating the document. This recording has been done after the last live webinar. During past recordings, only video was recorded and no sound. I'm Bree Rivera. I'm currently working with the ADE to assist with science professional development for science standards rollout. I'm a former ADE K-12 science specialist, and now you can find me at Mesa Public Schools as their secondary science specialist. What we are going to discuss today is what do science teachers need to know about the new science standards. To do this, we'll focus on what is three-dimensional science instruction, how to read the introduction section to the new science standards, the coding, how to read it and how it's useful, how to identify the three dimensions in the standard versus the learning progression, and since this is recorded after the fact, I will try to answer all of the questions that were asked during the 3 webinars that were live. First, we're going to discuss three-dimensional science instruction. Three-dimensional instruction is outlined in a framework for K-12 science education. The framework is a resource that outlines the vision for scientific literacy. That means what students need to know and be able to do to be scientifically literate by the end of 12th grade. It does this by laying out the 3 dimensions and how they are essential to science education in the classroom. So what is 3D learning? Let's talk about those 3 dimensions. The first dimension is the science and engineering practices that describes behaviors scientists engage in as they investigate and build models and theories about the natural world, and the key set of engineering practices that engineers use as they design and build models and systems. The framework uses the term practices instead of a term like skills to emphasize that engaging in scientific investigation requires not only skill but also knowledge that is specific to each practice. There are 8 science and engineering practices. The second dimension is the cross-cutting concepts, and they are taught in the context of instruction within the disciplinary core ideas and not in isolation. There are 7 cross-cutting concepts, and they deal with issues regarding patterns. So for example, middle school students recognize patterns on both the micro and the macroscopic levels, and high school students understand that patterns vary in systems depending upon the scale which that system is studied. In the middle of this image, you see dimension 3, the core ideas. The disciplinary core ideas have the power to focus K-12 science curriculum, instruction, and assessments on the most important aspects of science. These are the physical sciences, like chemistry and physics, earth and space sciences, life sciences, and using science in the everyday world. The core ideas are used to build a coherent progression of learning for students from kindergarten to the 12th grade. The framework has individual chapters dedicated to each of the dimensions of science instruction. Chapter 3 describes the science and engineering practices. Chapter 4 describes the cross-cutting concepts. And in chapters 5, 6, and 7, it describes the disciplinary core ideas in physical, life, and earth and space sciences. If you want to understand the new science standards, you need to become familiar with the framework. Don't read it from cover to cover, but become familiar with the aspects of three-dimensional science instruction. Instead of having you read sections from the framework, there is a video that explains how the 3 dimensions translate into classroom instruction. This video was created for the Next Generation Science Standards by Achieve. We are not an NGSS state, but because we are a framework-based standards state like NGSS, the information in the video can be applied to the new Arizona State Science Standards that were written from the framework by Arizona teachers for Arizona teachers. So as you watch the video, think about these questions. How do the Arizona Science Standards represent a shift in science education? What do the teachers in this video learn from engaging with the three-dimensional science instruction method? And how do the three dimensions work together? Go ahead and pause this video, follow the link on the screen, and I'll be back in a little bit. If you haven't had a moment to reflect on these three questions, go ahead and do so. Now that we have some understanding of three-dimensional science instruction, let's look at the document, and we're going to start with the introduction section to the new science standards. Please get out your copy of the Arizona Science Standards. If you printed them, flip along with me. On the ADE website under Standards/Science, you will find a PDF download of the new Arizona State Science Standards. When you download the full document, not the grade level documents, you will receive the full introduction of the standards as well. There are some important items in the introduction you should be aware of. Page 2 describes the vision of the standards. Pages 3, 4, 5, and 6 describe three dimensions of science instruction we briefly discussed. However, on page 6, the very last paragraph, it states that these core ideas occur across grade levels and provide the background knowledge for students to develop sense-making around phenomena in the natural world. With our new standards, phenomena is going to be an integral part of instruction. Page 7 is the time allotment suggested for each grade level. This was added to the introduction because of the integral role science plays in a well-rounded education, and they were a part of the design of the standards when they were written, to ensure a K-12 progression and to help set the expectations of teachers in the classroom. Here is a close-up of the recommendations for the time allotment. Go ahead and take as much time as you need to look at this page. Page 8 describes safety concerns, especially at the secondary level for science teachers. Pages 9 and 10 will help you understand how to read the code of the science standards. I'll go over these in more detail in a few minutes. And page 11 describes how to navigate the document. Again, we're going to take a closer look at this page shortly. The first goal in the new science standards is that science education will reflect the three dimensions of science learning. Second, that students engage in learning science by doing science, and that is explaining phenomena and designing solutions, and using those science and engineering practices to do so. Third, incorporating the engineering design process is a big innovation. Fourth, building coherent learning progressions across K-12 so that students are not learning disconnected facts, but they are seeing concepts develop over time and that there is an elegance in science. And the last goal is that science makes those connections and are cross-disciplinary to ELA and mathematics standards. Okay, now let's go back and look at how to read that code. On the screen, you see two standard examples. And let's look at the code itself. In these examples here, K stands for kindergarten and 2 stands for second grade. The standard designates the grade level in the coding in that very first letter or number. Next, you will notice a sequence of letters and numbers. Shown here are E1 and U1 in the example. This is the connection between knowing science, core idea E1, and using science, core idea U1. The last item is a number, and in this example, it's number 4. This tells us that this is a second grade's fourth standard. Therefore, when speaking in teams or with other teachers, it's easier to say, I'm working with second grade standard number 4, instead of 2.E1U1.4. This does not designate an order to teach the standards. It is just easier for recording and working purposes. This is a document you can find on the ADE website where the standards are found. This is the framework, Arizona Science Standard, snapshot. Hopefully you were able to already download this and maybe print it. But if not, go ahead and grab a digital copy. You will need it to help you to understand the code. I know that with three-dimensional science instruction, a lot of info was thrown at you. This framework and Arizona Science Snapshot helps organize the information on one page. The science and engineering practices, along with the page numbers they can be found on in the framework, can be seen in the blue box. The cross-cutting concepts, along with the page numbers they can be found on in the framework, can be seen in the green box. In the gold box, you have the core ideas for knowing science. And then in the purple box, you have the unique to Arizona science standards, the using science. Looking at the same example from the previous slide, you can reference the code on your framework and Arizona Science Standard snapshot. This allows you to see that E1 connects the core ideas of knowing science. Find E1 in gold, dimension 3, on the screen. This core idea focuses on that the composition of the Earth and its atmosphere and the natural and human processes occurring within them shape the Earth's surface and its climate. Every standard in the document, kindergarten through 12th grade, that is an E1, connects to this knowing science core idea. While students are learning content from core idea E1, they will also be using science. Find Arizona Science Standard U1 in purple on your snapshot. In the standard 2nd grade, the 4th standard, students should also explain the phenomena of how wind and water change the shape of the land from the standard by using evidence obtained from observations and/or scientific investigations. They can do this by developing models, using theory, or any of the science and engineering practices to make sense of the phenomena. And this is how the standards create a connection between knowing science and using science. Every standard in the document, kindergarten through 12th grade, that is a U1, connects to this using science core idea. If the standard was a U2, then teachers would be looking at this standard and helping students see it through an engineering lens. And if the standard was coded a U3, then they would help the students see this standard through a social and social implications lens. High school standards follow the same rules. However, high school is separated by content instead of grade level. So for example, L designates life science and P would designate physical science. There are essential standards that all high school students need to know, and they can be embedded into any class and will be a part of the state assessment. There are plus standards, and these make up traditional high school science courses. In the example, you see high school plus PHY. This stands for a high school physics course, and this standard is necessary to create a traditional physics course. It is not an honors or an extra standard. It is a required standard for a physics course, but it will not be on the state assessment. There are plus standards to create biology, chemistry, and earth and space courses along with physics. I know it seems strange to call them plus, but they are not honors or extra, but are necessary to create full year biology, chemistry, earth and space, and physics courses. Looking at the standards on the screen, the only difference between the two of them is that the standard on the left was intended to be on the state exam. The standard on the right was not. Now let's identify those 3 dimensions in the standard. Take a moment and look at the snapshot, and then look at the 6th grade standard example on the screen. What is the science and engineering practice, dimension 1, this standard identifies? What is the disciplinary core idea, or dimension 3, in this standard? In example 6.4, we can see the science and engineering practice is plan and carry out an investigation. And our core idea is objects on Earth are affected by gravitational forces. Okay, now try that on your own. Choose one of these 3 standards on the screen, go ahead and pause the video, and then identify where is the science and engineering practice, and where is the disciplinary core idea of knowing science. Okay, good. So in kindergarten, you found that the science and engineering practice was plan and carry out investigations. In 6th grade, it was analyze and interpret data. And in high school, it was also analyze and interpret data. Then for 2nd grade, the core idea of knowing science was P1. Specifically, heating or cooling can cause a phase change in matter. 6, 8 in high school are also P1 and connect back to that big idea that P1 talks about. And the last topic we are going to cover today that is very important is the standard versus the learning progression in the document. So the standard you will find in the left column of the document. Supporting material like the learning progression from the framework or the cross-cutting concepts will be found on the right hand of the document. The progression is not what should be taught. It is the research that was used to write the standard. It is there to give insight and perspective about the standard, but should not be used in determining exactly what to teach. Let me give you an example and then I will repeat that. So working with teachers, I asked them to go ahead and write on a poster, and I gave them a standard, and they were from different grade levels. I asked them to write on a poster what core ideas and content and learning is going to happen based on that standard. Write down everything you can think of. Well, looking at the two posters, they were very, very similar, even though they were different grade levels. And this is because they both had the same progression. The progressions are done in grade bands. So 3, 5, 6, 8, and we can see the progression multiple times in the document in different places because they are grade bands as long as they link back to that same core idea. So it's the standard that progresses over grade level. It is the standard that determines what should be taught, because if we looked at the standard in my example, they should have come up with different topics that were important to that standard. So the progression is not what should be taught. It is the research that was used to write the standard. It does give insight and perspective about the standard, but should not be used in determining exactly what to teach. Go back to the standard and always look at the standard for what to teach. By now, I've had you find 2 of the 3 dimensions in the standards document. Had you find the disciplinary core ideas and the science and engineering practices. But what about the cross-cutting concepts? Look at this document, pause it if you need to. Where do you see those cross-cutting concepts? Right, you're going to find them in the support section underneath the learning progression. And you may be wondering, why are some bold and why are some not? The bold cross-cutting concepts are the focus cross-cutting concepts for that grade level, and this only holds true for kindergarten through 8th grade. The non-bold cross-cutting concepts also make a strong connection to the specific standard to the left. These are suggested connections, all of them. Teachers may make other connections and students may make other connections, and if your students do make those connections and they are accurate, go ahead and support them in those connections. Whatever makes sense in the lesson. The cross-cutting concepts are a tool for students to make meaning of connections to other science concepts, so use them as that tool. So here you see the Arizona Science Standards and Assessment Tentative Transition and Implementation Plan. Yes, we did get new science standards in fall of 2018. However, this school year, 18-19, go ahead and continue to use the 2004 standards, and we will be given the same Ames science assessment as we have in the past, that is computer-based, covering the 2004 standards in grades 4, 8, and high school biology. Next year, the ADE suggests that if you can go ahead and do full implementation of the new science standards grades K-12, go ahead and do so. If you need a slower transition model, there are some examples on the Arizona Department of Ed website with the standards. So next year, 1920, begin implementation of the new 2018 science standards. We will be administering the same Ames science exam in spring of 2020 that is given in 4th, 8th, and high school biology, covering the 2004 standards. Then in the year 2021, continue to implement the new science standards. And the ADE is going to ask for a waiver for the Ames science in that spring of 21. They do need to ask the U.S. Department of Education for that waiver, and they're unsure of what that's going to look like, if it's going to be for all grades 4, 8, and high school biology, or if it's just going to be for 8th grade. But as soon as they know, they say they're going to let us know what that's going to look like. In the year 2021, we will be field testing the new science exam. The new assessment, if you look to the blue box on the right, will be in 5th grade, covering standards from 3rd, 4th, and 5th grade. It will be given in 8th grade, covering standards from grades 6, 7, and 8th. And it will be given in 11th grade, covering all of the essential standards in the high school document from 9th, 10th, and 11th. Because this is a recording after the fact, I did try to emphasize areas where there were more questions during the live webinar. If you want to, you can go back and listen to any portion of the webinar, but if you still have any questions, go ahead and email Sarah Sleesman at azed.gov. She's more than happy to answer your questions. Thanks so much.